Hi, this is Mr. McConley, and this is BKW General Physics class. And what I'm going to do is I'm going to walk you guys through the concept of current. Because we've been doing rate, we've been doing fluid flow rates and mechanical rates, like how fast, velocities. And now we're going to do electrical rate. And so I'm going to move the camera down. You might not see me very well from this point on, but you're going to be focusing your attention on the wiring. So, let's see here. It's pretty good. So at this point, what I can show you here is I have the electricity coming from the power supply in the table. It comes up to a switch. This switch can turn the lights on and off. And then it goes through one light bulb, a second light bulb, and back to the power supply. So it's a series circuit because the electricity only has one choice or one path that it can follow. So what we want to know now is if we're talking about flow rates, and we're talking about electrical flow rates, then you would have noticed from your slides presentation that you looked at yesterday that electrical flow rate is actually called current, the flow of current. It's the rate of electrons flowing through the wires. And it's kind of an invisible thing. It's not like water, because if this was water, we could see, oh, I can see how fast the water is flowing. I know what the flow rate is. I can calculate it by volume per time. Well, it's kind of the same concept, except you can't see the electrons flowing. The electrons are flowing, but you're trying to see how much charge of electrons is flowing in a given amount of time. To help us with this, we have a device, an ammeter. And an ammeter does specifically this. Amps is a measure of how much coulombs of electrons, or coulombs of charge, I should say, coulombs of charge are flowing in a given amount of time. So we are going to hook it up. Now the way you hook up an ammeter is as follows. You actually have to disconnect the circuit, so I'm going to pull this wire apart, and then in its place I'm going to now have the electricity flow into the meter, back out the other side, and to the light bulb. Okay? So now the electricity goes up through the switch, continues on this wire, goes to the ammeter, through the ammeter, to the light bulb, to the light bulb. It all seems to be working the same way. And if you can see on this meter, I'm not sure it's going to be clear or not, but I have it on the 500 milliamp scale, and it's reading about 240 milliamps, or to convert that, 0.24 amps. So what I can say right now is that the flow, the coulombs per second, the flow, the electrical rate of this circuit is 0.24 coulombs. I'm just going to look behind the camera and see if this is clear. Yeah, I don't know if you can read the meter, but I think you can see what's going on. So then, I might ask myself the question, well, I wonder how it would change the flow rate if I were to, say, remove the light bulbs, removed, and instead hook up, let's say, a little fan. So I have a little fan going here. Sounds like it has a little bit of a bad bearing. You could hear it a minute ago. But this fan is spinning away, and lo and behold, if I check my meter again, I actually am at 310 milliamps, or 0.31. So I actually have more electrons, or coulombs per second, flowing through this circuit with this fan. So what that tells you is that this is drawing more current, or drawing as a way to say it's pulling, it's using more current. So this particular setup pulls a bunch of current. So what we're going to do is I'm pretty much going to end the video at this point, and I'm going to start a new video that you'll watch on the following day, and that'll be on parallel circuits. So for right now, this is Mr. McConley with BKW General Physics.